this video we are going to start a new point. Point is acids and bases. In the last video we have seen what is ionic equilibrium, what are electrolytes, what are non-electrolyte, what is a strong electrolyte and what is a weak electrolyte. Now in this video we are going to start new point. The point is acid and bases. So now there are total three theories regarding to the acid and bases. Number one, Arrhenius theory. Second one, bronsted Lowery theory, and last one is a Lewis theory. So firstly, we will understand what is Arrhenius theory. And according to the Arrhenius theory, definition of acid and definition of base. Now, according to the Arrhenius theory, what is acid? Acid is a substance which contains hydrogen and produces H plus ion when dissolved into the water, dissolved into the aqueous medium. For example, HCl. When we dissolve HCl in aqueous medium, which means when we dissolve HCl in water, it gives us H plus and Cl minus ion. So the substance when dissolved into the water aqueous medium, it gives us H plus ion. That is why HCl is called as acid according to the Arrhenius theory. So what is acid? Acid is a substance which contains hydrogen and produces H plus ion when dissolved into the water, dissolved into the aqueous medium. Now this theory is applicable for weak electrolyte also. For example, acetic acid. Acetic acid is a weak electrolyte. So CH3COH, when dissolved into the aqueous medium, it gives us H plus ion and acetate ion, CH3CO minus. So here also the substance when dissolved into the aqueous medium, when it dissolved into the water, it gives us H plus ion. That is why this substance is also called as acid according to the Arrhenius theory. So according to the Arrhenius, acid is a substance which contains hydrogen and produces H plus ion when dissolved into the water. So that is what the definition of acid. Now, according to the Arrhenius theory, what is base? Now, according to the Arrhenius theory, base is a substance which contains OH group and produces OH minus when dissolved into the water, dissolved into the aqueous medium. For example, NaOH. When we dissolve NaOH in aqueous medium in water, it gives us Na plus plus OH minus. So this one, NaOH contains OH group, and when we dissolve NaOH in water, it gives us OH minus group. So that is why NaOH is called as base according to the Arrhenius theory. Second one, NH4OH. NH4OH when dissolved into the aqueous medium, it gives us NH4 plus plus again OH minus. So this substance gives OH minus ion when dissolved into the water. Also, this substance when dissolved into the aqueous medium, it also gives us OH minus ion. So that is why both substances are called as base. So what is the definition of base according to the Arrhenius theory? Base is a substance which contains OH group and produces OH minus ion when dissolved into the water, dissolved into the aqueous medium. So that was regarding the definition of acid and definition of base according to the Arrhenius theory. Now, what are the limitations of Arrhenius theory? Now, there are 2 to 3 limitations of Arrhenius theory. Number one, limitation of Arrhenius theory. Arrhenius theory is applicable to aqueous solution only. Arrhenius theory is applicable for aqueous solution only. Means if the condition is non-aqueous, means in gaseous phase, this theory is not applicable. So you can identify the given substance is acid or base only in terms of aqueous solution, means dissolving into the water. So this is the first limitation of Arrhenius theory. Arrhenius theory is applicable for aqueous solution only. It is not applicable for gaseous medium or non-aqueous phase. Second one, Arrhenius theory does not explain the acidic nature of substances which do not contain hydrogen. For example, copper sulfate, ferrous sulfate, sulfur dioxide, carbon dioxide, BF3, AL3, all these are acid one. They do not contain hydrogen, however, they are acidic. So these substances, copper sulfate, ferrous sulfate, SO2, CO2, they do not contain hydrogen, even though or however they are acidic one. Why they are acidic one? Which is not explained by the Arrhenius theory. Likewise, Arrhenius theory does not explain the basic nature of substance which do not contain OH group. For example, ammonia, NH3, sodium carbonate, they are basic. They do not contain OH group, however, they are basic one. Why they are basic? Which is not explained by the Arrhenius theory. So that was regarding the limitations of the Arrhenius theory. So in basis, which is bronsted-Lowery theory. So according to the bronsted-Lowery theory, what is acid and what is base, means definition of acid and definition of base. So according to the bronsted Lowery theory, acid is a substance which donate H plus and base is a substance which accept H plus from the another substance. So according to the bronsted-Lowery theory, acid is a substance which donate proton, which donate H plus to the other substance. And according to the bronsted-Lowery theory, base is a substance which accept the proton, accept H plus from the another substance, where H plus is called as proton. Let us consider one example regarding to the bronsted-Lowery theory. HCl react with ammonia NH3 giving us NH4 plus Cl minus ion. Now in this reaction, look at this reaction. In this reaction, HCl is converted to Cl minus ion by donating H plus ion. So here HCl is converted to Cl minus ion by donating H plus ion. By donating H plus ion. So we can say that HCl is a acid. So HCl is a acid one. Because according to the bronsted-Lowery theory, acid is a substance which donate H plus, which donate proton to the other substance. So here HCl donate H plus to the NH3 and convert it to Cl minus ion. That is why according to the bronsted-Lowery theory, HCl is a acid one, because according to the bronsted-Lowery theory, acid is a proton donor one. Now look at the second reactor. NH3 is converted to NH4 plus. Means here NH3 converted to NH4 plus by gaining H plus or proton from the another substance. That is why NH3 is called as base. NH3 is called as base. So HCl is an acid while NH3 is a base. Why HCl is an acid? Because HCl donate H plus or donate proton to the other substance. That is why HCl is an acid. And why NH3 is a base? Because NH3 accept H plus, accept proton from the another substance. That is why NH3 is a base. So HCl react with NH3 to form NH4 plus Cl minus ion. Now we are going to reverse the reaction. Means NH4 plus combined with Cl minus ion to form NH3 and HCl. Now out of these two, if I am going to reverse the reaction, out of these two, NH4 plus and Cl minus ion, which is acid and which is a base? So according to bronsted-Lowery theory, what is acid? Acid is a proton donor, means donate H plus, while base is a accept H plus. So here, if I am going to reverse the reaction, NH4 plus combined with Cl minus ion, then NH4 is converted to NH3 by donating proton H plus. That is why NH4 plus we call it acid. And in the second reaction, when we talk about second reactant, Cl minus is converted to HCl by gaining H plus. So that is why Cl minus is what? Cl minus is a base. So NH4 plus is acid because it donate H plus and convert it to NH3. So this is a proton donor. That is why it is called acid. And Cl minus is converted to HCl by accepting H plus. So accepting H plus proton, that is why Cl minus is a base. So according to the bronsted-Lowery theory, acid is a substance which donate proton, which donate H plus to the other substance. And according to the bronsted-Lowery theory, base is a substance which accept H plus from the another substance or which accept proton from the another substance. So according to this theory, HCl is an acid, NH3 is a base. And when I am going to reverse the reaction, in case of NH4 plus is an acid and Cl minus is a base. Now this reaction contains two pairs of acid and bases. For example, HCl converted to Cl minus ion, means this is one pair of acid and base. So HCl and Cl minus ion is a one pair of acid and base. And also the reaction contains second acid base pair, which is NH3 is converted to NH4 plus, means this is also acid base pair. So we have the second pair of acid base in this reaction, NH3 and NH4 plus, where NH3 is a base, NH4 is an acid, and here HCl is an acid and Cl minus is a base. Means this reaction contains two pairs of acid and base, that we call it conjugate acid base pair. So HCl and Cl minus ion is a conjugate acid base pair. Also ammonia and NH4 plus are is the conjugate acid base pair. So these two are conjugate acid base pair. Acid base pair. So in case of bronsted-Lowery theory, the reaction contains two acid base pair, two conjugate acid base pair. Now what is the definition of conjugate acid base pair? Conjugate acid base pair are those which differ by H plus only, which differ by proton only. For example, when you look at the first conjugate acid base pair HCl and Cl minus ion, these two acid base pair differ by only H plus. So these two means conjugate acid base pair differ by only H plus means proton. So this is called H plus. So because in case of HCl and Cl minus, what is the difference? The differ by only one H plus. Here also NH3 and NH4. The differ between NH3 and NH4 plus will be H plus. The differ between NH3 and NH4 plus, that will be the H plus. So look at the conjugate acid base pair. This conjugate acid base pair differ by only H plus, differ by only proton, and that pair is called conjugate acid. Explain the last theory of acid and bases, which is a Lewis theory. And according to the Lewis theory, what is acid and what is base? Means definition of acid and definition of base. So according to the Lewis theory, acid is a substance which accept electron pair. Means acid is a substance which is an electron pair acceptor, and base is a substance which electron pair donor. Means according to the Lewis theory, acid is a substance which accept electron pair from the another substance, and base is a substance which donate electron pair to the other substance. So let's take an example which explain the Lewis theory in terms of acid and bases. For example, BF3 reacted with ammonia. Now BF3 is called as acid and NH3 is called as base according to the Lewis theory. Now why it is called acid and why it is called base? Because NH3 contain this lone pair of electron. Means NH3 have excess electron in terms of lone pair of electrons. So because NH3 have excess electron, ammonia is electron rich one. So ammonia is electron rich. Because it is electron rich, it donates electron to the another substance. So NH3 is called as base because NH3 contains excess electron, and means ammonia because contain excess electron, it is electron rich one, that is why it donate electron. So that is why it is called as base. So and first reactant, when we consider first reactant BF3 is an electron deficient one. Why it is electron deficient? Now look at the central atom of BF3B, boron. Now boron contains only 6 electron in its valence shell, means 2 plus 2 plus 2 means 6 electron, means it requires 2 electron to attain octet, means it is short of 2 electron, it needs electron. Because it needs electron, it is electron deficient one. So this is BF3 is electron deficient. Why BF3 is electron deficient? Because it needs electron. It contains only 6 electron in its valence shell, means it required 2 electron to attain octet. So that is why, because it contains 2 electron short, it is electron deficient one. And why ammonia is electron rich? Because ammonia contains excess electron in the form of lone pair of electron. So because it is electron rich, it donate electron pair to the boron atom in case of BF3. And because it is electron deficient, BF3 accept electron pair from the ammonia. So ammonia donate electron pair to the BF3 and BF3 accept electron pair from the NH3. That is why NH3 is called base and BF3 is called acid. So according to definition of acid, acid is a electron pair acceptor. Because here BF3 accept electron pair from ammonia. That is why BF3 is acid. Acid means electron pair acceptor. And when we consider base, base is an electron pair donor. Here, which is base? Ammonia. And ammonia donate electron pair to the BF3. That is why electron pair donor is called base, means NH3 is a base. Now look at the final compound. When BF3 reacted with ammonia, it formed compound BF3 coordinate covalent bond between nitrogen boron and ammonia NH3. So we have the final compound BF3NH3. So in this way boron complete its octet, and this bond is coordinate covalent bond because both electrons donate by the nitrogen to the boron. So that is why the bond between nitrogen and boron is coordinate covalent bond. So according to the Lewis theory, BF3 is a acid because acid is a substance which accept electron pair from the another substance, and according to the Lewis theory, base is a substance which donate electron pair to the another substance. So this is how we consider three theories regarding to the acid and bases. First one, Arrhenius theory, second one bronsted Lowery theory, and last one is a Lewis theory.